The next speaker is Dr. Rosana Colussi. Dr. Rosana Colussi is Professor of Food Science and Technology at the Center for Chemical, Pharmaceutical and Food Sciences at the Federal University of Pelotas in Brazil. Her research focuses on quality control, technological process, bakery products, starch modification, and digestibility. And the talk of our presentation today is physical treatment applied to potato starch alters its structure and functionalities.
Good afternoon. I'm Rosana Colussi, professor from Federal University of Pelotas, Brazil. And my presentation is about physical treatment applied to potato starch alters its structure and functionalities. So there is several reasons for modify potato starch. It is well known that native potato starch has high swelling capacity, which leads to a high viscosity and a raw texture. And there is some limitations that we also can alter applying the modification. There is several types of modification that can be applied to a potato starch for modify its characteristics, like chemical, physical, enzymatical, and also genetic modification, but our research group has been focusing on physical modification, physical treatments, because it's a green technology which is eco-friendly, and we can find very, very nice results. So the main focus was in heat moisture treatment and the hydrostatic pressure and the double modification, like a hydrostatic pressure and a retrogradation. Today I will show some results about the study that we apply HHP cycles associated with retrogradation. So in this study, we apply two pressures, 400 NPa and 600 NPa, for 3 cycles of 10 minutes and 6 cycles of 10 minutes. So after that, the starch was dried and stored for determinations, and another part of the starch was stored for 7 days at 4 degrees. So, and also was dried for determinations. The main results that we found in this study was that the 6 cycles was enough for the modification of the starch, and the number of the cycles resulted in an increase of the peak viscosity, breakdown, and the sit-back viscosities of the starch. And the same behavior has been found for both pressure, 400 NPa and 600 NPa. When applied the retrogradation, we can verify here in this yellow one that there was one decrease in the peak and the breakdown and also in the sit-back. We also verified the relative crystallinity, and the HHP promotes the reduction of the relative crystallinity, but when applied the retrogradation after HHP, especially when used the higher pressure, there was one increase in the crystallinity. Another very interesting result of this study was the microstructural characteristic of the starch gels. So we verified that the native starch gels has one opening network, and with the application of HHP, the network was smaller. There is smaller spaces, and these spaces was reduced with the retrogradation. And the gelatinization and the retrogradation of the starch are the main determinants of its functional properties during the processing and the digestion. So for this, we submitted the starch gels for starch digestibility, and we verified that the only HHP did not differ from native starch, but when we applied the retrogradation after the HHP, we verified a very slower digestion of this starch. So we concluded that the application of HHP with or without the cold storage promotes changes in morphology, in passing, thermal, and crystallinity properties, and also in the structure of the gels and the in vitro digestibility. The greatest changes, this study was found when we applied 600 MPa using 6 cycles of 10 minutes. And this food processing technique can be applied for consumers that require a smaller and slower digestion of starch. So thank you for your attention.
Thank you, Professor Rosana Colussi, for a great overview of the effects of retrogradation on production of potato starch with HHP.